Welcome. Here's our second proof. All right, so we're going to, in this proof, we're going to show that both pairs of opposite sides are parallel by showing they have equal slopes. All right, so we are still on the parallelogram proofs. All right, we're going to do 4 of them. All right, our first step is we need to graph. All right, so first step is our graph. All right, so you're going to graph the point -3, 0. Label that K. You're going to graph the point -5, 7, and label that L. You're going to graph the point 3, 5, and label that M. And then graph the point 5, -2, and label that N. Right? And when you connect, you're going to go in order. Right? Go from K to L to M to N. Go around the figure. Right? And I'm just going to connect. I'm smart enough to save it so I don't have to worry about trying to make lines while I'm taping. So L, and then I'll connect K to L, and then L to M, and M to N, and M to N, and then N back to K again. Right? I'm not going to draw the diagonals in this one because we are not proving anything with diagonals. Step number 2, what do we want to show? We're going to show that both pairs of opposite sides are parallel. That S looks really weird. Right? And how are we going to do it? What formulas are we going to use? We're going to use the slope formula. Actually, I'm trying to switch colors each time just to make it stand out each step. Slope formula. Right? And the slope formula, we take the difference in the y coordinates divided by the difference in the x coordinates. Step number 4, we have our work. Right, so we need to find all 4 slopes. Right? Let's go in order. All right, let's go with a pair of opposite sides. All right, so I'm going to do LM, and then I'll do KN, and then I'll do KL, and then we'll do NM. All right, so LM. All right, so it's nice and big up there. I'm not going to bother to write it on the diagram. I think we can see those points really clear. All right, so we have 7 minus 5, difference in the y coordinates, and then -5 minus 3, and that's going to be 2 and -8 in the denominator. Right, so that reduces to -1/4. Always reduce. Right? What if I had 2 8s and 4 16s and I didn't recognize that those are the same things, right? So always reduce. Right, so now we want to find the slope of Kn. Right, and so we have 0 minus a -2. So that's the same as +2. And then -3 minus 5. Right, so that's going to be +2 in the numerator and -8 in the denominator, and that reduces to -1/4. More space. I'm just going to keep on going, and then maybe I'll go up a little bit too. All right, so it's a good thing I color coordinated it. So everything in black is our work. All right, so now we need so we can see that those 2 have the same slope. How about the other 2 pairs of sides? Because remember, it's not enough to have one pair of opposite sides parallel. That's a trapezoid. We need 2 pairs. All right, so now let's find the slope of LK. All right, so 7 minus 0, and then -5 minus a -3. So that's 7 in the numerator. that'd be negative 5 plus 3. So negative 5 plus 3 is a 2, and that doesn't reduce. And then we need the other pair of opposite side, the other side opposite LK would be MN. All right, so it would be 5 minus, that's going to be the same as 5 plus 2. And then 3 minus 5. Wait, make sure I started with the right one. 3 minus 5, yeah. Oh, excuse me. There's a mistake in LK. And nobody said anything. Were you at home saying, whoops? Negative 5 plus 3 is negative 2. Let me fix that. And you can see the line goes down left to right. Negative 2. Which is good because 3 minus 5 is also negative. So this would be 7 over negative 2. All right, we have our work. All right, we can see we've got both pairs of opposite sides have the same slope. All right, so that does mean that they are parallel to one another. So now let's write our proof. I'm going to do a 2-column proof in this one as well. All right, so our proof, we have to have these statements. And for every statement, we have a reason. All right, so we always start with the information that we are provided. All right, so we are provided K, L, M, N. We're given, you don't have to write down what the coordinates are for each of those. All right, we're saying we know that we have the coordinates for K, L, M, N. How do we have those coordinates? It was given to us. All right, then what did we do with those coordinates? Well, we found out that LK has a slope. So I'm just going to put LK, M is usually used for slope, right? M equals 7 over negative 2. And I'm going to put MN right next to it. And really those are segments, so those are line segments. I should have a line over them. MN, that was a slope of, again, 7 over negative 2, or negative 7 halves. And then we found this, well, actually, first we found, but I'm going to writing it the way I see it on the board here. We found the slope of LM. And the slope was negative 1/4. And then we have the slope of KN. Well, how do we know all that information? Well, we use the slope formula to find it. I have enough room here for my proof. I don't need many steps. Right? So now that we can see our slopes, we realize that LK is parallel to MN, and LM, just put the lines across it, those are segments. LM is parallel to who am I missing there? LM is parallel to KN. That thing is an N. How do we know that? Right, so now, our reason number 2 was one of our formulas. Reason number 3, then we work from that. Right? Because they have the same slope, they must be parallel. Because we know parallel lines have the same slope. Well, as we can see from the diagram, if we have two pairs of opposite sides that are parallel, it means that KLMN is a parallelogram. And which reason did we use to prove it's a parallelogram? We showed that KLMN has two pairs of opposite sides parallel. So you could write a quad that has two pairs of opposite sides parallel, or you can say KLMN, it's got 4 points, that means it's a quadrilateral, has two pairs of opposite sides parallel. And there we go. That's all there is to it. All right? So notice it uses oh darn it, I did not mean for that to separate. All I wanted to do was move it for you. So notice that it uses formulas from algebra, and then it uses definitions and postulates, and I can't find my cursor, there we go. Definitions and postulates from geometry so that we can complete our proof. And we are done, so I'm going to end this video. All right, in the next Nearpod, we will do the other 2 parallelogram proofs. Thanks for watching. Bye for now.